Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a Calculus 1 lecture. I hope you enjoy it. Alright, in this video, I just want to go over more examples from 3.1. Alright, so here we go. So let's start with finding the derivative. Alright, so let's say that I have f of x is equal to 7x minus 3, right? And first we're going to recall that our derivative definition. And the derivative definition is that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, all of this over h. Alright, so I'm going to be applying that into this example. So I get that f prime of x is equal to, well, if I plug in x plus h, I get 7 times x plus h, and that was supposed to be an h. There we go, 7 times x plus h minus 3 minus 7x minus 3, all of this over h, and look at that, I forgot to write limit. Well, I didn't mean to erase that, I wanted to shift it over. So I forgot to write limit, so we had to make sure that we write limit. Limit as h goes to 0. Alright, so now what do we get? We get the limit as h goes to 0 of, if I distribute that 7, I end up with 7x plus 7h. We still have a minus 3. If I distribute that negative 7x plus 3, right? Negative times a negative is a positive. All of this over h. At that point, we see a few things cancel out. 7x and negative 7x cancel out. Negative 3 and positive 3 cancel out, giving us the limit as h goes to 0 of 7h over h. These h's cancel out, giving us the limit as h goes to 0 of 7, which is just 7. Now that should make sense because, again, if you recall, the derivative is just the equation for the slope. So what we have here is that f prime of x is just 7, which makes sense because we had a linear equation, so the slope is 7. All right, but now let's look at scenarios where it is not a linear equation. All right, so let's say example B. Let's say that my function f of x was x squared minus 5. And now to figure out f prime of x, I'm going to say, well, that is the limit as x approaches, not x, as h approaches 0 of, well, our difference quotient, right? And I'll write it again. F of x plus h minus f of x, all of this over h, which gives us the limit as h goes to 0 of x plus h squared minus 5, right? That's me plugging in x plus h into the first part, into our function, minus x squared minus 5. That's just our f of x, and all of this over h. At that point, we say that's the limit as h goes to 0 of expanding this x plus h quantity squared. Well, that's x squared plus 2xh plus h squared. We still have a minus 5. Distributing this negative, minus x squared plus 5, all of this over h. At that point, we see that x squared cancels out with a minus x squared. This negative 5 cancels out with this plus 5. And on the numerator, everything that we have left still has an h, right? So what we can do here is we can factor out that h from the numerator. So I have h times 2x plus h, all of this over h. And there, these h's cancel out. So I just end up with the limit as h goes to 0 of 2x plus h. And if h is going to 0, that gives me just 2x when I evaluate it. So when I evaluate the limit. So that means that f prime of x is equal to just 2x. All right. Next one. So that's B. C. Let's say that I have f of x being equal to x cubed plus x squared. And again, we're looking for the derivative. Perhaps I'll shift this down one line so it's not so blocked. Okay, there we go. Way better. All right, and this was that. All right, so in here, again, f prime of x is the limit as h approaches 0, and that was supposed to be an h. All right, f of x plus h minus f of x, all of this over h. What this is going to give me now is the limit as h goes to 0 of, well, I'm plugging in x plus h. So I have x plus h cubed plus x plus h squared minus, well, just f of x, which is going to be x cubed plus x squared. And all of this over h. So now we have the limit as h goes to 0. Now I'm going to expand this x plus h quantity cubed. Actually, you know what? Before I expand that, let me show you how there is an easy way to expand things like that. So in general, if I have something like a plus b to the n, all right? So in here, we have something called Pascal's triangle. And Pascal's triangle is drawn like this. I start with a 1, then a 1 and a 1. Then I'm always going to start with a 1 in each new line, 1. But this next number is going to be the sum of these two. So 1 plus 1 is 2. And I'm also going to end with a 1. Similarly, I end up with 1, 3, 3, 1. Right? I started with a 1. I added these two. I added these two. And then I ended with a 1. Similarly, I end up with 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, so on and so forth. Now in here, what this actually does, it gives me the coefficients of something that's in the form of a binomial to the nth power. In this first line, n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. And this triangle can be expanded as far as you want, right, if you wanted to keep going. But again, what this does is gives me the coefficients. So that tells me now that if I'm going to do it to the third power, right here I have it to the third power, well, if I have a plus b to the n, my coefficients are going to be based out of this line. All right, so I have 1, 3, 3, 1. The next thing I'm going to do is I'm going to start with these ABs, but I'm going to start with a first. And this was a plus b to the third. All right, so this becomes, I'm going to start writing the a's, and I start with a cubed. That's a cube, and then they start going down by power. So this is going to be a squared, then a to the 0, which we don't write. The next thing I'm going to look at is this b, and I'm going to do a very similar pattern, but I'm going to go the other way. I'm going to start over here with b cubed, then b squared, then b to the 0, which is nothing, and then because these two, this is positive, everything here is positive. If it had been negative, a minus b to the third, we'll start the same way, 1, 3, 3, 1. And then with the a's, the same exact thing, a cubed, a squared, a, and then nothing. But now with the b's, with this negative b, all right, a negative to a third power, well, hold on. The b's, the same exact thing, first b cubed, b squared, b, and then no b's. But now with these negatives, in here, since it was raised to there was a negative to a third power, a negative to a third power is negative. Now over here where I have the b squared, at that point, this is being squared. That negative squared is positive. The next one, to the first power here, right? This is the b to the first power. So with that negative in front, it stays negative. So that's essentially what that becomes. But for this specific problem, we're going to be using this idea right here. So that limit, so now let's continue with the limit. The limit now becomes the limit as h goes to 0 of, let's expand that numerator. So it's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed, right? That was just using x and h's instead of a's and b's, plus x plus h quantity squared is x squared plus 2xh plus h squared. minus, distribute that negative, so minus x cubed minus x squared, and all of this over h. Now let's see what cancels out here. We have an x cubed here, we have a minus x cubed there, those cancel out. We have an x squared here, we have a minus x squared there, those cancel out. And notice that everything that's still left has an h. All right, so because everything that's still there has an h, we can factor out an h. So we have h times 3x squared plus 3xh plus h squared plus 2xh. All right, no, not 2xh, 2x. I'm factoring out 1h. Plus 2x plus h, right? So this 3x squared h, so on and so forth. Right, I took out an h out of everything there, and I'm left with an h on the bottom. And at that point, we see that the h on top cancels out the h on the bottom, giving me just the limit as h goes to 0 of 3x squared plus 3xh plus h squared plus 2x plus h. But since h is going to 0, this here goes to 0, that goes to 0, that goes to 0, leaving me with the final answer, well, with the limit, actually, no, with the final answer, there we go, because now I'm evaluating the limit as that h goes to 0. So what I'm left with here is just 3x squared plus 2x. All right, let's do another one. Let's say that I had, so that was C. Let's do D. Let's say that I have f of x is equal to 1 over x minus 1. All right. So in here, if, well, we know what the limit definition of our derivative is. The limit as h goes to 0, and that's an h. The limit as h goes to 0 of f of x plus h minus f of x, all of this over h. So what this gives us is the limit as h goes to 0 of, plug in the x plus h, so I have 1 over x plus h minus 1 minus 1 over x plus h, all of this over h. Now in there I have a fraction inside of a fraction, so we can rewrite this now as limit as h goes to 0 of 1 over h times 1 over x plus h minus 1 minus 1 over x plus h. At that point, well, what happens? Let's see. You get, I'm going to combine these two, all right? I'm going to come up with a common denominator. So I have the limit as h goes to 0 of 1 over h times, my common denominator is going to be x plus h minus 1 times x plus h, not x plus h, I messed that up, look at that. This should not be x plus h, that should just say x minus 1. So this right here should just say x minus 1. And this right here should just say x minus 1. All right, there we go, way better now. So the numerator, what does it become? Well, in this first one, I had to multiply it by x minus 1. This next one, I had to multiply it by x plus h minus 1. So at that point, if we expand the numerator, so we have the limit as h goes to 0 of 1 over h times, and here I have x plus h minus 1 times x minus 1 as my denominator. Getting rid of parentheses, my numerator becomes x minus 1 minus x minus h plus 1. And at that point, we see a few things cancel out. This x cancels out with this minus x. This negative 1 cancels out with this positive 1. So our limit now becomes the limit as h goes to 0 of negative h over h times x plus h minus 1 times x minus 1. And from there, these h's cancel each other out. So our final answer here, well, let me just rewrite what this limit is. So we have the limit as h goes to 0 of negative 1 over x plus h minus 1 times x minus 1. And since h is going to 0, that means that this piece right here goes to 0, just the h, right? So if I evaluate this limit now, I end up with -1 over x minus 1 squared, right? This first parenthesis is just x minus 1, and x minus 1 times x minus 1 is x minus 1 squared. So what I found out here is that f prime of x is -1 over x minus 1 squared. All right, let's do a similar problem. That was D. So E, let's say that f of x was, let's do simple, -1 over x squared. All right, so again, we're going to start by writing down our limit definition. So let me shift that up a little bit. All right, way better. So I'm going to say the limit as h goes to 0 of f of x plus h minus f of x over h. That's our definition of f prime of x, right? Our derivative. So what we're going to get here is the limit as h goes to 0 of plug in x plus h. So I have -1 over x plus h squared minus -1 over just x squared, right? And all of this over h. And again, here I have fractions over fractions. We don't like that. So I'm going to rewrite this down as the limit as h goes to 0 of 1 over h times -1 over x plus h squared. Distributing this negative, I end up with plus, right? Negative times a negative is a positive. So plus 1 over x squared, which now what I can do here is come up with a common denominator. So I have the limit as h goes to 0 of 1 over h times, well, my common denominator, x plus h quantity squared times x squared. All right, so that's the common denominator that I get there. On the numerator, I end up with -1 multiplied by x squared, so -x squared, plus the quantity of x plus h squared, right? Just multiplying those two to the numerators. Expanding that numerator, I end up with the limit as h goes to 0 of 1 over h times, well, my denominator, again, was just x plus h squared times x squared. My numerator, that -x squared stays the same, plus, if I expand this x plus h squared, I end up with x squared plus 2xh plus h squared. At that point, we see that some stuff cancels out. -x squared with a positive x squared. And the stuff that's still in the numerator, everything has an h, right? Everything there has an h. So because everything that's left in the numerator has an h, we can factor out an h. So I'm left with the limit as h goes to 0 of 1 over h times, well, what are we left with? 2x plus h, all of this over x plus h squared, x squared. And at that point, you'll see, well, that the h in the numerator and the denominator cancel each other out. So what I get now is the limit as h goes to 0 of, well, my numerator is just 2x plus h. My denominator is now x plus h squared times x squared. But since h is going to 0, this goes to 0, this goes to 0. So I end up with 2x over x to the fourth, right? This is just x squared. X squared times x squared is x to the fourth, giving me here 2 over x cubed by canceling out that x. At this point, we can say that our final answer now, our f prime of x, is going to be just 2 over x cubed. All right, that's our derivative. Next one. So that was E. F. Let's say that I had the following. F of x being equal to the square root of 2x. All right, so we're going to find the derivative of that. So here, again, we'll start with writing our definition. F prime of x is equal to the limit as h goes to 0 of the difference quotient. So that's f of x plus h minus f of x over h. Applying this x plus h into here, I end up with the limit as h goes to 0 of the square root of 2 times x plus h minus the square root of 2x, all of this over h. Now, at this point, what we need to do is we need to manipulate this because we know that we somehow need to cancel out that h in the denominator. So what we can do here, well, there's always two things we can do to any math problem. Those two things are add 0 and multiply by 1. In this case, I'm going to multiply by 1, but that 1 is going to be the conjugate of the numerator. So we have 2 times x plus h plus the square root of 2x over the square root of 2 times x plus h plus the square root of 2x. All right. Notice that in the numerator, I've got the product of conjugates. If you recall, the product of conjugates is the difference of squares. All right. So what I get now is the limit at h goes to 0 of the square root of 2 times x plus h squared minus the square root of 2x squared. All of this over h times radical 2 times x plus h plus radical 2x. All right. At that point, well, what do we see? We see that the numerator, I have square root squared, so we can rewrite the numerator a little bit. The radical and the square cancel each other out. If I distribute this 2, I end up with just 2x plus 2h minus, again, the radical and the square cancel each other out, so I end up with just 2x there. All of this over h times the square root of 2 times x plus h minus the square root of 2x. At this point in the numerator, you'll notice that the 2x's cancels out, right? 2x minus 2x is 0. So what are we left with? Well, we're left with just stuff that contains h in the numerator. And let me just finish copying down this denominator. All right. So at that point, we see that the h's cancel each other out. So we end up with the limit as h goes to 0 of 2 over the square root of 2 times x plus h minus the square root of 2x. But since h is going to 0, this piece right here goes to 0. So I'm left with just 2 over, well, here I have radical 2x plus radical 2x, giving me 2 over 2 radical 2x. Those 2's cancel out, so I have 1 over radical 2x. All right, and that would be our final answer. In here, f prime of x would be 1 over radical 2x. All right. All right. Let's do one more like these where we're just finding the derivative, and that was f. So g. So I have here f of x is equal to negative 1 over radical x. All right. So here we go. Again, we start by writing our definition. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, all of this over h. In this case, that means the limit as h goes to 0 of plug in x plus h. So I have negative 1 over the square root of x plus h minus f of x. And f of x was just negative 1 over radical x, and all of this over h. So that gives me now the limit as h goes to 0 of, I'm going to rewrite this because I don't like fractions over fractions. All right. So, well, minus negative becomes plus. There we go. So that's what we end up with there. And then at this point, I'm going to say, well, let's come up with a common denominator. So in here, the common denominator ends up being radical x plus h times radical x, right? And the numerator now becomes, well, this is going to be negative radical x plus positive radical x plus h. And that's a negative sign over here. There we go. Now, at this point, well, we need to somehow cancel out that 1 over h, right? So what I'm going to do here again is what I did on the last example. All right. And what did I do on the last example? I multiplied by 1. So we're going to multiply by 1 in this case. All right. So that 1 is going to be, well, the conjugate of what we're working with. But first, I want to rewrite what we're working with. All right. I have a negative plus. I'm just going to rewrite that in a different order. So I'm going to rewrite this as the limit as h goes to 0 of 1 over h times the square root of x plus h minus the square root of x, all of this over radical x plus h times radical x. All right. So in here, that's what I'm going to multiply by the conjugate. So the conjugate is going to be radical x plus h plus radical x over radical x plus h plus radical x. All right. And now, well, we know that the product of conjugates gives us the difference of squares. So we can rewrite this now as radical x plus h squared times, minus radical x squared. And on the bottom, I've got the radical x plus h, I've got radical x, and I've got radical x plus h plus radical x. In the numerator, well, those radicals and the squares cancel each other out, right? So I end up with x plus h minus x. On the denominator, I don't feel like writing it again, so I will copy and paste it into here. There we go. I'll get rid of that though. All right. So that's what we end up with at that point, and then we have an x minus x in that numerator. So the x minus x cancels out. So what I get now is the limit as h goes to 0 of 1 over h times h over that entire thing again. So I'll just paste it again. All right. And at that point, we see that the h on the numerator and the denominator cancel each other out. So what I get now is just, oh, I didn't want to write in yellow. What I get now is the limit as h goes to 0 of, well, essentially just this part, right? And all of this 1 over that. So since h is going to 0, well, let's see what happens here. This part right here goes to 0. This part right here goes to 0. So our limit now evaluated becomes 1 over, and I'll do it in multiple steps, radical x times radical x times radical x plus radical x, right? And in here, notice that this part right here just becomes 2 radical x. This part right here just becomes x. So what I get here is 1 over 2x radical x, which I can rewrite as 1 over 2x to the 3 halves, right? This is x to the 1 half, this is x to the 1. Add up the exponent, 1 plus 1 half is 3 halves. Okay, so that was just some more examples of derivatives. Now, I want to do more examples with finding the equation of a tangent line, but it's going to be slightly different than what I did in the other video. So that example was for letter G. So here we go, H. So the question says, find the equation of the tangent line of f of x that is parallel to the given line. So here we've got f of x being equal to, let's say we have 2x squared, and the line is going to be 4x plus y plus 3 is equal to 0. All right. So the very first thing I'm going to do here is, well, since we need an equation of a tangent line, right, then that means that we need a slope. We need a slope and we need a point. So the very first thing I'm going to do here is try to figure out what the equation for the slope is. And the equation for the slope is just f prime of x, which is just the limit as h goes to 0 of f of x plus h minus f of x over h, which in this case gives me the limit as h goes to 0 of 2 times x plus h squared minus 2x squared, right? Perhaps I'll do them with brackets in that parentheses. So now all of that is over h squared, right? So now I get here the limit as h goes to 0 of 2 times, if I expand this, I end up with x squared plus 2xh plus h squared minus 2x squared, all of this over h. I don't know where I got the h squared from. That's supposed to be just h. There we go. Way better now. Now, let's distribute that too. If I distribute that too, well, what do I get? I end up with 2x squared plus 4xh plus 2h squared, right? And in there, we see that I have this 2x squared minus 2x squared, so that cancels out. So what I'm left with here now is the limit as h goes to 0 of 4xh plus 2h squared over h. Notice that everything on the numerator has an h, so I can factor it out, and I'm left with 4x plus 2h, all of this over h. These h's cancel each other out. So so what do I have there? I have the limit as h goes to 0 of 4x plus 2h. At that point, since h is going to 0, this piece right there goes to 0, and we're left with 4x. All right. So what we have here is that our formula for the slope is going to be 4x. Okay, let's set that aside. Now, let's recall what I had here. We want it to be parallel to this equation. All right, well, let's rewrite that equation. So first so it's 4x plus y plus 3. 4x plus y plus 3 equals 0, right? And in here, if I solve for y, I end up with y is equal to negative 4x plus 3, right? So now, what does this tell me? We wanted the equation of the tangent line to be parallel to this line. So because it has to be parallel, that tells me what the slope should be. The slope should be negative 4. So in here, I get the slope is negative 4. Over here, I had that the slope was 4x. So if I set 4x equal to negative 4, this tells me that x is equal to negative 1, right? And if x is equal to negative 1, well, that's going to imply the point that we're talking about, right? We need to figure out what point it is, because we need a slope and a point. We've got the slope, now we need a point. And to do so, I'm going to plug in that one in there, that negative one, excuse me, in there. So I'm going to say f of negative 1 is 2 times negative 1 squared, which is just 2. So in here, these 2 points, or these 2 lines, give me the point negative 1 comma 2. So now, we've got our slope. Our slope is negative 4. And we got a point, negative 1, 2. So to find the equation of that line, right, well, we have a point and a slope, point, slope, point, slope, point, slope formula. So we have y minus y1 is equal to m times x minus x sub 1. At that point, plug in our point and the slope. So we have y minus 2 is equal to negative 4 times x minus negative 1. X minus negative 1 is really x plus 1, right? And from there, I'll continue up here. If I distribute out that negative 4, I end up with negative 4x minus 4. If I move the 2 to the other side, I end up with a plus 2. So that gives me that y is equal to negative 4x minus 2. All right, so this is the equation of the tangent line that is parallel to the given line. and it happened at the point -1, 2. Notice that we weren't given much information to begin with. All we said here was, this is the function, this is the line that we want it to be parallel to, figure out the rest. All right, and through that I was able to find a point as well as a slope. All right, next one. So that was what letter was that? H. So I. So here's example I. Let's say that we had f of x being x cubed plus 2. All right, and we want it to be perpendicular to the equation of 3x minus y minus 4 is equal to 0. All right, so I'm going to start this in the same exact way. First, I'm going to find my generic formula for slope, which is f prime of x. So in here, this gives me the limit as h goes to 0 of f of x plus h minus f of x, all of this over h. So once I do that, I'm going to plug in the x plus h. So what do I get? I end up with the limit as h goes to 0 of x plus h cubed plus 2 minus x plus h cubed, but no, minus x cubed plus 2, minus x cubed plus 2. There we go. Way better. Way better when we don't make mistakes. All right, so now at this point I end up with the limit as h goes to 0 of, expand the numerator, x cubed plus 3x squared h plus 3xh squared plus h cubed plus 2, distribute that negative, minus x cubed minus 2, all of this over h. And then we see, well, a bunch of stuff cancels out here. X cubed minus x cubed goes away. 2 minus 2 goes away. And everything that's left here still has an h. The stuff that didn't cancel still has an h. So what we can do is factor out that h from the numerator, and we're left with 3x squared plus 3xh plus h squared, all of this over h. And we see, well, we have an h on the bottom and an h on the top, so those cancel each other out, giving us here the limit as h goes to 0 of 3x squared plus 3xh plus h squared. And since h is going to 0, we've got a few things there going to 0, that goes to 0, that goes to 0, right? And from there we say, well, that's going to give us now our evaluated limit of 3x squared. So that is going to be f prime of x. All right, and again, that's the formula for the slope. The slope is going to be 3x squared. Now, at that point, what we need to figure out is, well, something that's perpendicular to the given line. Well, what was the given line? 3x minus y minus 4. 3x minus y minus 4 equals 0. Solving for y here, I end up with y is equal to 3x minus 4. All right, so in here, the slope for this equation is 3, right? But we want it to be perpendicular to this. So the perpendicular to that, so this perpendicular slope, and perhaps I'll write it with a slightly different, the slope that's perpendicular, there we go, will be the negative reciprocal, which is how I get negative 1/3. All right. In this case, well, what we see here is that we have 3x squared is equal to negative 1/3. So that tells me that x squared is equal to negative 1. So in here, this has no real solution. So what this tells us now is that there is no line, there's no tangent line to 3x to the function x cubed that is perpendicular to that. All right. Now, so this also, that has no real solution, so it implies no tangent line is perpendicular to, so no tangent line to f of x. So perhaps I'll shift this over. No tangent line of f of x is perpendicular to the given line. But what about parallel? All right, and that's my, well, that looks like an 11. Didn't mean to look like that. Let's say, what about parallel? All right, so parallel. So what was the slope that we had? M was 3x squared, and the equation of the line was 3x minus 4. So x was 3x squared, and the equation of our line was y equals 3x minus 4, right? Let me just verify that. Yes. So in there, we had that the slope is just 3. So if I set 3x squared to be 3, well, if I divide both sides by 3, I have x squared is equal to 1, so that x is equal to plus or minus 1. So in here, we actually have 2 points at which the equation of the tangent line would be parallel to that line y equals 3x minus 4. So let's see what happens when x equals 1. When x equals 1, well, then our slope is 3 times 1 squared, which is 3. Also, when x equals 1, well, then our function, so f of 1, gives us, well, if you recall, the function was x cubed plus 2, right? Where is it? There it is, x cubed plus 2. So we're going to have 1 cubed plus 2, which is just 3, right? So our slope is 3, and the point that we have here is 1, 3. So what we can do now is we can say that y minus y sub 1 is equal to m times x minus x sub 1. So y minus 3 is equal to m. M was 3. 3 times x minus x sub 1 was 1. So we have, if I distribute that 3, I get 3x minus 3. If I move this 3 to the other side, I get plus 3. So y is equal to 3x. All right, that negative 3 plus 3 cancel each other out. So that was a scenario when x equals 1. Now, when x equals negative 1, well, what do we get? We get that our slope is 3. Let me rewrite that. That our slope is 3 times negative 1 squared, which is just 3. My function, that's f of negative 1, well, that's going to be negative 1 cubed plus 2. Well, negative 1 cubed is negative 1. Negative 1 plus 2 is positive 1. So this gives me now the point negative 1, 1. And now, applying the same exact idea, we end up with y minus y sub 1 is equal to m times x minus x sub 1, right? That's our point slope formula. And in this scenario, that means y minus 1 is equal to m times x minus negative 1. All right. So if I let's rewrite that a little bit. So we have y minus 1 is equal to 3 times x plus 1, right? Minus a negative is just plus. So if I distribute that 3, I end up with 3x plus 3. If I add 1 to the other side, I end up with y equals 3x plus 3 plus 1. So it's y equals 3x plus 4. So in here we have two equations that happen to be parallel to the tangent line of x cubed plus 2. All right. And again, we found that there was no perpendicular line because, well, the slope would have needed to be a negative value, but our general formula for the slope was always positive because of the square. All right. All right. So that's just a couple of extra examples from 3.1. All right. And I'll end it there. Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.